So welcome to another class of the Making Music with Arduino. Here's Gustavo Silveira and welcome to this class. In our last class we learned about MIDI, and now that you already know how to mount a basic circuit in the Arduino, how to read a button, and about the MIDI protocol, so now it's time to mix everything using this button to send a MIDI note to your preferred software. So today we're gonna work with the libraries. So what are they? The Arduino IDE can be extended through the use of libraries. So these libraries, they give the Arduino IDE an extra functionality that you can use inside your sketch. So for example, if we want to use MIDI, there is a library that we can use that will give us a lot of shortcuts to work with MIDI. So for example, in the last class, we learned how the MIDI protocol works in the bit world, for the machine language with bits, where we saw that it has a 8-bit resolution and etc. So for us to use this in the code, we would need to go deep there in the bits and bytes and how it works and write thinking in bits. So it would be kind of hard to do that. So it would be really complex. So instead of writing this low-level language like near the machine language, we use a library that will give us shortcuts for using that. So instead of writing everything like for the machine language, we will just use the shortcuts that will be called by the library. So we're gonna add this library, and during our code we will write certain lines of code in a certain syntax that will call this library. It will access a code that is inside this library and it will realize a determined task. So we add the library, and then it will help us with shortcuts that will go inside the library and do something for us, okay? So today we're gonna work with the Arduino MIDI library that we're gonna make our life much easier working with MIDI inside the Arduino. So put MIDI library on Google, and probably you're gonna come here. So click there and download the latest version. Come here to the end and download this Arduino MIDI library. I already downloaded it. It is here. So instead of clicking here 2 times, if you click here 2 times, you will open those folders. You have examples and etc. But before doing that, you come here to your IDE, come in Sketch, Import, and Add. And then you go to the folder where you can find your library, where you downloaded. Mine's here. So select this, the zip file. You can select the zip file and just add it. Because I already did it, I'm not going to do it again. And it will appear here, our MIDI library. So let's see here in this folder, because always those libraries, they come with a lot of really useful examples where you can start working or learning about the library. So let's see here this basic in and out. Let's see what we have here. So notice here that we have include here and MIDI.age. So always when you use a library, you need to include the library, because if you don't include it, you will have an error. You can't use it. So first thing here, we have this include and this MIDI create default instance. So always when we use the MIDI library, we need to write this in the beginning of the code, the include MIDI, just like it is here, and this MIDI create default instance, just like it is here. This way we can use the MIDI library. So let's continue here. Here it has a define LED 13. Actually, this is exactly the same as creating a variable like this. Int LED equals 13. But the difference is actually the same thing as creating a constant int. So it's a variable that's not going to change during the code. When we put the const, it means that this variable, the LED, is not going to be modified during the code. As it is a pin, we are not going to change the pin number. So we can use this other kind of declaring. It's the using the define LED 13, and we don't use the equal sign here. So let's come here to the setup. Here we define the LED, the pin 13, as an output, and here there's something new. MIDI.begin 4. So MIDI is a communication, so for us to start this communication, as we need to start the serial communication, we need to start the MIDI communication like this, MIDI. And remember that capital letters are different, and so it matters. So if it is capital, put capital. So here, MIDI in capital letters, dot begin, and between parentheses, 4. Launch MIDI and listen to channel 4. What it means. Remember in the MIDI language that MIDI has a channel, that's 16 channels. Here you put which channel you want to communicate in your MIDI. This code here, we are not going to see exactly because we are gonna see a different thing, because here it's reading MIDI, but we want to write MIDI. So we are not going to do this, at least in this class. I just wanted to show you here how you need to start your code. Include MIDI create instance and initialize the MIDI with MIDI begin. So now we are gonna go to our code that we made where we were reading the button. I'm going to upload this code and just one thing. I'm going to close this and you're going to understand why I'm doing this. Okay, now uploading. Let's remember what it has. Here I declare my two variables, the pins, the button pin and the LED pin, 2 and 13. Remembering that Arduino comes with an embedded LED in the pin 13. My variables that are the state of the button and the previous state of the button, because I need to compare both, because if it was pressed and now it's not pressed, do something. And if it is not pressed, if it was not pressed, and if now it's pressed, do another thing. So it's just for comparing the previous state with the actual state. Serial begin to use the serial monitor. And here, I'm not going to details because we already saw everything. And here, button on, button off, on, off, on, off. And there is a mistake here because it's going right besides the button on, because I forgot to put the LN. Remember that print LN, like line, print line, means that it puts a new line, but I forgot to put in the node off. So let's see here. And I apologize because I forgot to turn my camera on, so it's just the screen. But you can see that's working fine. So first, what we need to do, we need to make it communicate as a MIDI controller. So as we need to work with MIDI, we need to include now our MIDI library. So let's open an example here. So just let's copy and paste to the beginning of our code. So okay, I already included here. So what we want to do now? Now we want to communicate with the computer through the USB port. The Arduino uses the serial protocol to send data through the USB port. And what is serial? Is a kind of protocol, just as MIDI is a kind of protocol. So Arduino doesn't send MIDI natively through the USB port. There are some ways to do it, but we are not going to see now. But from scratch, the Arduino doesn't send MIDI, so it sends serial. So what we're gonna do is send serial and then convert into MIDI in the computer. So let's initialize here, like MIDI.begin. If we don't put anything here, it means that we are using channel 1. And here in serial begin, that was 9600. 9600 is like one frequency, like a radio frequency, but it's the baud rate, where we are going to tune this frequency to read the Arduino data. So for example, in the serial monitor, you're going to choose which baud rate you're going to use. So we were using 9600, but as I told you, the Arduino will send serial and then it will convert it to MIDI in another software. So we're going to use a software to convert this MIDI. And this software works in a baud rate, which is the 115200. So in our codes, always when you use serial communication to send serial, then will be converted to MIDI, we will use this baud rate. So that's it for now. See you next class.